Hi everyone, welcome back to Java 1 for All. In this video we are going to talk a little bit more about behavior parameterization, and we are going to see how we can improve a lot the code that we did in the previous video. So first, what we are going to do, we are going to extract the business complexity. We are trying to use here what we call strategy pattern, and we are going to apply that through an interface. So let's create here a package called interfaces with s at the end, and then let's create here an interface called car predicate. So this interface will have only one method. It will be called test, and it's going to return a boolean. Cool. And what we want to test, well, I don't know exactly what the test will do, but I know that I want to test a car. The package is zzb parameterization. Okay, now let's copy the behavior parameterization class, Ctrl+C, then Ctrl+V, and let's wipe everything that we have and leave only one. Okay, so let's leave this for now. Now I actually can delete as well. Okay, we were filtering by color and we tried different approaches, but now we are going to do something a little bit different. We are going to rely on the polymorphism, and we want to pass through the parameter the behavior that the if must have. How are we going to do it? First, we are going to rename this to filter, and I have the list of cars, but I'm going to ask for a car predicate, and let's call it predicate. Now the only change I'm going to do is I don't know what is the test, but I know that the test will be predicate.test and then the car that I have here. Pretty cool. How can we actually pass now the behavior of the test? Very simple. We can call filter and we pass the list of cars like always. But now, since we are working with interfaces, we need a concrete class, and we know how to work with anonymous class. We just have to call new and directly the car predicate, very similar to what we did with a comparator. And here I'm going to define the business logic, that is car, this car right here, dot get color dot equals green. Semicolon here, introduce local variable, let's call green, and salt green. Ctrl Shift F10, and we have the green color. Now I want to have another one, red, and here we change to red, and here we change to red as well. So basically I just duplicated, but now it's another behavior that we are passing to the same method filter. Ctrl Shift F10, and we have the color red. Now you see that IntelliJ is telling something to us. We can use Lambda Expression. Basically, Lambda Expression is the new syntax introduced on with Java 8 that allows you to achieve the same thing but with fewer lines. So for example, this we can change it into the following. First, the syntax is you must give a name to the, it's like a variable, like if you are using for each a reference variable, you give a name. This could be car, this could be X, this could be anything, and it's the same thing here, because the Lambda expression is going to simplify this entire creation. So I just want to use car, and as you can see, we have this arrow syntax now. So now car is my reference variable. As you can see here, car is of type car. How does it know? Because of this. Since I only have one option, that's the test method, Java knows already what can be done. And now I can just copy this. So basically this car dot get color dot equals red. Ctrl Shift F10, and we have the same results. Can we change this to green? Yes, we can change this to green as well. So here we do the same, or you just press Alt Enter and let IntelliJ fix that for you. So as you can see, look at the number of lines that we were able to reduce just using Lambda's expression. Ctrl Shift F10, and everything is working perfectly fine. You can also do the year, so year before, and we did with year, if I'm not wrong, it was 2015. Yeah, so car.getYear lower than year. So car.getYear, but we don't have the year anymore. We just have to pass it here. It could come from somewhere else. Control Shift F10, actually Control D, and then add another one. There you go. So I have all the cars with year before 2015. As you can see, the behavior is going through the parameters now. So basically only one method, and it doesn't matter. I could call this from anywhere else in our system, and we would be able to pass different behaviors. And we can even go ahead, go further ahead and apply some generics. You know how generic works. So for the car predicate, we were being very, very specific, but we have in Java something that was created for us. Inside java.util.function package, you have a class called, guess what? Predicate. Well, guess it's not helping. Let me do something there. Predicate. There you go. I just want to open this one. There you go. So you have a functional interface. It's an interface where you only have one abstract method. Everything else here, as you can see, has a body. And we have the same test. Exactly the same thing. The difference is that this interface is generic. It can be applied to anything. Car, computers, any object that we have in our system. So basically, this is what we are going to do. We are not going to use car anymore. We're just going to use car with the predicate created by Java. Now, how can we do that? Let's do the following here. We can create another class. I can change this one. So we can just move this to predicate. And you provide, instead of the T, what's the type you are working? Car. And everything should work exactly the same way. Cool. Now, how can we create a generic method that will filter anything that we pass? Let's copy this class, replace it here with 3. And now we're going to do the following. Forget about this. Let's start from scratch. I want to create a generic method, but my class is not generic, so I need to define the type explicitly. So the type will be T. What I'm going to return, I have no idea. So the type will be defined in the future. And this is going to filter. Now, I'm going to get a list to filter. A list of, I don't know, T. And I'm going to apply the predicate. For what? I don't know, T. And I will do exactly the same thing as I did before. So I will create a list of filter things. I don't know the type yet. Filter. And I'm going to create a for. So filter, Alt Enter, iterate. So T. We rename to E because this is element and is not this one. I want to iterate over this list. Cool. Now, if predicate.test, what I'm testing, this E right here. Filter.add this element from the for, and at the end we just return the same thing that we have in previous methods, the filtered list. Cool. Technically it should work exactly the same. Let's try. Control Shift F10. So as you can see, test 03, test 03, we have exactly the same result, but now the difference is the following. I can create here list integer numbers list.off 1 2 3 4 5 6 7 8 9 10, and we can do directly into the salt. So I want to filter the list of numbers, and what's the logic that I want? I want only the even numbers. Let's give a name to the reference variable. Let's call num, and then the syntax is arrow, and the condition. Basically, num should return all the even numbers. Control Shift F10, and as you can see, we have the even numbers here. So basically, as you can see, anything can be passed, any list can be passed, and any condition can be passed through parameter. So this is what we say behavior parameterization, because the behavior is coming as a argument to this method right here, filter. So technically, you can only have one function to kind of fix different kind of problems. So now, if your client comes and say, hey, I would like to filter by black cars, I want to filter year lower than 2012, technically it's done. You just have to provide that functionality. So everything here could come from somewhere else. For example, could come from a UI, or could come from a file, from a database. So it doesn't matter if you provided this parameter to come from something that the client is working with. Well, you don't have to worry. You can just tell him you can do it yourself. So this is how it works. I hope you enjoyed. See you in the next video. Bye.